In this video, we are going to look at how we can convert between mass in grams to moles of one substance. And the way we're going to do that is through our molar mass. So through this video, you will be able to use molar mass molar mass of a molecule as a conversion factor to convert between mass in grams to moles. And so our first step before we can even do our conversion is we need to know our molar mass. And the way that we are going to do that is by finding the atomic mass for each individual element in the molecule and then adding the mass for every atom that there is. And I'll show you what that looks like. So molar mass is the mass in grams for 1 mole of a substance. And like I said, our first step is we need to find our atomic mass of each element in the molecule. And the molecule that we are going to be working with is Na2O. So if we go to our periodic table and we find Na is right here. The number that is our atomic mass is our decimal number, this bottom number. So our atomic mass of Na is 22.99, and we're going to round to our second decimal place. Because there is a 0, we don't have to change it. So mass of Na equals 22.99 grams. Our next step is that we have to find our mass of oxygen, because that is the other element in our molecule of Na2O. So on the periodic table, oxygen, it has the symbol O, and that is right there. Our atomic mass of oxygen is 15.999. So if we round to the second decimal, because the third decimal place is a 9, it's going to push it up, which makes our mass of oxygen 16.00 grams. So now that we have found our atomic mass of each element in the molecule, we have to take account for how many atoms of each element that we have in this molecule. And so we're going to multiply our mass by the number of atoms. So for Na, because Na has the subscript of a 2, that means that there are 2 Nas in 1 mole of Na2O. So we're going to go ahead and multiply 22.99 grams by 2. And then we're going to do the same thing for oxygen. So in Na2O, oxygen doesn't have a subscript behind it. And so what that means is that we just have 1 of oxygen. So we can multiply 16.00 by 1. And if we were to calculate this, 22.99 times 2 is 45.98 grams. And then 16 times 1 is 16.00 grams. So our last step after we multiply the atomic mass of each element is we need to add them together to find our total mass. So we found the mass of each element so far by using the atomic mass. And then we took account for how many atoms of each element are in the molecule. Our last step is to add it all together. So if we do 45.98 grams plus 16, our answer is 61.98 grams per mole. So for 1 mole of Na2O, our mass is going to be 61.98 grams. So now that we know how to find the molar mass of a molecule, we can start converting. And using that number as our conversion factor, to help us get between grams and moles of a molecule. So our first question is, how many grams of Na2O are produced if there are 7 moles of it? So same setup as before, our known number times our new units over our old units. Our conversion factor for this question is going to be our molar mass, because we know that for every 1 mole, we're going to have 61.98 grams. So our known number is the number that they give us to start with, and that's going to be 7 moles. They want us to find how many grams of Na2O. So our known is also going to be our old units, because that's what we start with. So after we change to the units they want our answer in, they're going to be our old units. We don't need them anymore. So we're going to go ahead and put our known number up front, which was 7 moles of Na2O. Next, we are going to use our conversion factor. But before we can even put our numbers in there, we need to know what units go on top and what units go on the bottom. Well, we know our old units are going to be the same units that we start with. And the units that we started with was moles of Na2O. Our new units are what they want our answer in. And so from the question, we found that our new units are grams of Na2O. So now that we know which units go where, we can go ahead and match our number. So because our conversion factor is going to be our molar mass, we are going to match the numbers that are with our units in our molar mass to the units in the parentheses. So for 61.98 grams for 1 mole, 61.98 is with grams, so we're going to put that with that up top, and then it's per 1 mole, so we're going to put 1 on the bottom. Give me 1 second as this loads. Okay, so now that we have this all set up, we can go ahead and calculate. So 7 moles of Na2O times 61.98 over 1, we can put that in a calculator exactly like we see it. So 7 parentheses, up top we're going to have 61.98. On the bottom we're going to have 1. Finish that off, and our answer is 433.86. And grams of Na2O. So does this answer make sense? Well, we know that for every 1 mole of Na2O, there's 61.98 grams. So if we have more than 1 mole of it, our answer as our number has to be bigger than 61.98, which it is. It's 433.86. So we're going to do this again, but we're going to do it the opposite direction. So we went from moles to grams. This time we're going to go from grams to moles. So our question this time is, how many moles of Na2O are produced if it's 200 grams of Na2O? So we know that our known number is the number they give us to start with. And that's also going to be our old units, the grams are. Our new units are what they ask for. And so they're asking for moles of Na2O. That's what we want. So those are going to be our new units. Our conversion factor is still going to be our molar mass because we're still going from grams of the one substance to moles of the same substance. So we are going to use that to help us figure out if we have a certain number of grams, how many moles should that be? So we're going to go ahead and write our known number first, which we said was 200 grams of Na2O. And we're going to do our parentheses. We said our old units are the same as what we start with, so that's going to be grams of Na2O. And our new units are going to be moles because that's what we want. So we're going to put that up top. Now we just match our numbers that are with our conversion factor to those units. So 61.98 grams per 1 mole. With grams, we have 61.98. And then with mole, we have 1. Now we're going to go ahead and calculate that. 200. Up top we had 1. On the bottom we had 61.98. Our answer is 3.23, and I rounded to the second decimal. And our units are moles of Na2O. Now, does this make sense? Well, we know, again, for every 1 mole, we have 61.98 grams. So if our mass is bigger than 61.98 grams, our number of moles should be bigger than 1, which it is. So this answer does make sense. So again, to convert between the moles of one substance into the grams of the same substance, so it's still the same substance, the same molecule, you're just changing from moles to grams, you're going to want to use your molar mass. The way you figure out your molar mass is by using your periodic table to find the atomic mass of each element, then taking account for how many atoms of each element you have, and then adding it all together at the end. And then your setup is the same as it's always been for your conversions. You start with your known number up front. In your parentheses is going to be your conversion factor with your new units, what they want your answer in from that conversion up top, and your old units on the bottom.